curious, expansive. The Milky Way is a vast, chaotic river containing billions of stars. To find our exact cosmic address, we have to zoom in, past the galactic center, to find our local neighborhood, the solar system. At the center sits the sun. It holds over 99% of all the mass in the system, creating a gravitational pull intense enough to force every surrounding celestial body into a continuous, looping path. For a celestial body to qualify as a true planet, it must satisfy a strict requirement. It has to orbit the sun in a dominant and fixed path, clearing all other debris from its orbital lane. This requirement is why Pluto was reclassified. Its path is erratic and actually intersects with the orbit of Neptune. Because it does not dominate its own lane, it was demoted to a dwarf planet, or Vamangras. The 8 remaining planets follow a strict hierarchy. They are locked into a regulated gravitational dance, where their positions are determined by the sun's mass. These 8 worlds are highly organized, split into 2 distinct families. They are segregated not just by distance, but by their physical and chemical makeup. Between the orbits of Mars and Jupiter sits the asteroid belt, a rotating ring of cosmic rubble that acts as a physical boundary line between the inner and outer system. On the sunward side of this wall are the terrestrial, or Parthis planets. On the far side, beyond the rubble, sit the Jovian giants. Crossing this belt represents a transition from a realm of heavy metals and silicates to a region dominated by volatiles like hydrogen, helium, and methane. Mercury, Venus, Earth, and Mars share a common architecture. They are small, dense, and built from solid rock and metal. Mercury sits closest to the sun, absorbing unfiltered radiation. Because it lacks an atmosphere to regulate heat, its surface temperature fluctuates by hundreds of degrees between day and night. Venus, the second planet, is even more extreme. Its atmosphere is nearly 97% carbon dioxide, which traps solar energy and creates a permanent, blistering bake across the entire surface. Venus also exhibits a kinematic anomaly. It spins in a retrograde direction, meaning its rotation is reversed compared to the rest of the inner planets. Earth follows, the only terrestrial world with a protective ozone layer that filters ultraviolet radiation, maintaining the liquid water necessary for life. Mars is a frozen red desert. Its thin atmosphere and rocky crust host some of the most dramatic geology in the system, including Nix Olympica, a volcano that towers over any mountain on Earth. This inner realm is defined by intense radiation and solid ground. It is a neighborhood of rocky surfaces and volatile atmospheres. Past the asteroid belt, solid ground disappears. The planets become massive spheres of swirling gas and liquid. Jupiter is the undisputed king of these worlds. It contains more mass than all other planets combined and spins so fast that its equator bulges visibly. Saturn is characterized by its expansive ring system and a remarkably low density. Despite its size, its mass is distributed so thinly that the planet could theoretically float in water. Further out sit the ice giants. In 1781, William Herschel expanded our understanding of the system when he discovered Uranus. Uranus is oriented at an extreme 98-degree axial tilt. It effectively rolls on its side as it orbits, while also maintaining a retrograde spin. Neptune marks the final frontier. It is a freezing, deep blue world battered by high-speed winds and located billions of miles from the sun's warmth. The Jovian realm is a domain of immense pressure and swirling fluids, environments where the sheer scale of gas and ice makes the solid ground of the inner system impossible. Gravity dictates how these planets move. Every world in the system is locked into a state of continuous motion. Rotation, or paribrahman, is the spin of a planet on its axis, creating the cycle of day and night. While spinning, every planet maintains a path around the sun. This is revolution, or parikraman. One full lap dictates the planet's year. These mechanics regulate the passage of time. A world's year and day are determined entirely by the speed of its orbit and the rate of its spin. Proximity to the sun dictates orbital speed. The closer a planet is to the sun's gravity, the faster it must travel to maintain its orbit and avoid falling inward. Mercury is hugged against the sun, forcing it to complete a year in just 88 days. On the frozen edge, Neptune travels so slowly that a single lap takes 164 Earth years. Gravity and orbital velocity hold the system in a state of continuous equilibrium. Every planet sits in a specific, stable position, maintained by the speed of its own flight.